1,000-kilometer orbit, the solar panel of the lunar craft will be deployed. A series of in-plane corrections to reduce the height of the craft from the lunar surface will place it in the 200-kilometer near-circular orbit. After the performance check of the lunar craft and its orbit around the Moon for a week or two, the altitude will be further reduced to 100 kilometers to put the lunar craft in the final designated polar circular orbit. With the placing of the lunar craft in this orbit around the Moon, the study objectives of the mission will be initiated. For the next 2 years, the lunar craft will circle the Moon and collect remote sensing data following a strategic plan of imaging of the different regions of the Moon. Let's look at the major mission objectives and the intended payloads to achieve them. The mission aims to obtain a high-resolution, three-dimensional atlas of the whole Moon with spatial and altitude resolution of 5 and 10 meters respectively. The image system on board the lunar craft is the Terrain Mapping Camera, or TMC. The TMC is a stereoscopic imaging instrument operating in the panchromatic spectral band to produce 3D digital map. A laser altimeter will supplement and complement the data generated by the TMC for better definition of lunar shape evaluation or the lunar topography. This instrument will also function as an altimeter for the lunar craft. With these payloads, the mission is equipped to focus on some large basins and scientifically interesting craters, like the 2 craters named after the famous Indian scientists Dr. Homi Jahangir Bhabha and Dr. Jagdish Chandra Bose, as well as regions close to North and South poles. Besides the cartographic mapping, mineralogical mapping will also be carried out. The hyperspectral imager with wedge filter, or popularly called high-psi, will generate the spectroscopic data in a spatial context all through in the 400 to 900 nm spectral range, which will give us the mineral composition. The low-energy X-ray or LEX spectrometer will measure the fluorescent X-rays in the energy band 1 to 10 keV. Since the fluorescence X-rays produced by various major elements present in moon rocks are excited by solar X-ray flux, the intensity of solar X-rays and their energy will be measured by X-ray monitors installed on the lunar craft, which will be viewing the sun all the time. On the other hand, high-energy X-ray hex spectrometer will cover the 15 to 200 keV region. The mission would explore the entire lunar surface for various elements. This study also targets on high atomic number and radioactive elements. Can these studies take us nearer to the understanding of the evolution of the Moon? Probably yes. These studies should give us new insights to understand the composition and chemical evolution of the Moon. The data collected by all the payloads on board the lunar craft will be stored on solid-state recorders. The stored data will then be downlinked in X-band by the gimbaled steerable antenna. The lunar craft will be working in its orbit and collecting data round the clock uninterrupted at a distance of about 400,000 kilometers from the Earth. The power requirement of the lunar craft during its 2-year mission life will be met through single-sided solar panel, generating 630 watts of power. For operations and in the eclipse time, the lunar craft will have built-in lithium-ion battery. The critical payload data generated by the lunar craft will reach the Earth through the Indian Deep Space Network. Equipped with a 34-meter diameter reflector and the latest gadgetry, the Indian Deep Space Network will be constructed at Bangalore. The payload data received at the ground stations will be transferred to the National Science Data Center, which will act as a repository of scientific data. Here, the data will be converted to user-friendly form to be studied and deciphered by the scientific community. The first Indian mission to the moon will be the result of meticulous planning, extreme precision, and continuous hard work put in by the Indian scientific community. The mission is aimed at human betterment and knowledge enrichment with 2 signposts: affordable cost and minimum realization time. And this mission is just a beginning. The beginning to open up newer horizons lying beyond the solar system. This is not a page from science fiction. Neither is this exercise for status or prestige. But yes, it is a dream. A dream with the solid foundation anchored in our scientific strength. The strength of the second largest scientific manpower and decades of committed space research. The aspiration of the Indian space program has always been enrichment and betterment of society. Can we then afford to ignore it now?